my dear students. In this session, I'll be explaining about the solution of linear equation involving three variables like x, y, z. We already discussed about the pair of linear equation in our lower classes where we have got the two sets of equation involving x and y. Now we are going to find out the another variable, that is z also, x, y, z. So in that case we have got three equations. So we have here 3x minus 2y plus 3z is equal to 8. This is equation number 1. And 2x plus y minus z is equal to 1. That is equation number 2. Then 4x minus 3y plus 2 is equal to 2z is equal to 4. Now we are going to solve this equation. So when I say solving the equation, it is nothing but the finding out the values of x, y and z. So do you understand? Now we are going to employ a determinant method for solving these equations. Now let me introduce the concepts behind this problem. So here we are supposed to find out the x value by multiplying the A inverse with the B. And similarly, what is A inverse? The inverse of A is nothing but 1 by determinant of A into adjoint of A. Let me explain about this. Now, we have to separate these equations into coefficient and the x, y, z variables. So, in this case, I have taken all the coefficients of the x, y, z. For example, what is the coefficient of x? 3. The coefficient of y in the first equation is minus 2. So I have taken separately. So I have isolated the coefficient. Okay, right. And I have taken all these x, y, z as a, what do you call this? Yoga you can come here. So what do you call this is a Yogeshwaran. So here, what do you call this matrix? Is a column matrix, is it not? It's a single column. Okay, so we have separated into two. Okay, so can you get the same equation, that is LHS of the set of equation, by multiplying these two?
Sure.
How?
If you want to multiply means first we have to take the a11 variable and multiply with the a11 variable and then add the a12 variable into a12 variable.
Very good. So this is the multiplication method where we go by row by column multiplication. Are you will follow? So 3 minus 2, 3. So all these elements should be multiplied by this single column. And secondly, we have to produce like this. And thirdly, you have to produce. So you will be able to get the same equation. So for our convenience, we have split this into two matrices. So what about this matrix? What is the order of this matrix?
3 by 3.
3 by 3. What is the order of this matrix?
1 by 3.
1 by 3. Why? Because is it 1 by 3?
3 by 1.
3 by 1. Why? Because there are
3 rows and 1 column.
It's also called
column matrix.
Okay, got it. Now, what is this B, which is nothing but a single column matrix of the constant values 8, 1, 4. Got it? So now we have what is A, the matrix, what is X, X, Y, Z, that is the variable we are going to find out, and what is B, it is the constant single column matrix. I hope now you should be able to understand. You can employ these two formula. The first formula is, in order to find out the x, that is the solution. X means x, y, z. Okay. So to find out this one, we can multiply the A inverse with B. What is B? This is B. What is A inverse? We have to find out A inverse. So to find out A inverse, what you are supposed to do, you can adopt the adjoint technique, where the reciprocal of the determinant A into the adjoint of A, that results the A inverse. So we can make use of this strategy, right? Now, and before proceeding with the adjoint, what we are supposed to do, Yogesh?
We have to find out the determinant of the matrix A, and then we have to find the cofactors of matrix A. Then we have to transpose the cofactors as adjoint of A. Transposing means interchanging the rows and columns.
Okay, so before finding out the cofactors, what we are supposed to do?
Before finding the cofactors,
This one, is it not?
yes sir. For the determinant, we have to find whether the determinant is non-singular matrix and whether it is invertible or not.
So what is the condition for non-singular matrix?
For non-singular matrix, the determinant should not be equal to 0.
Very good. So now we have got the determinant. So we have to work out the determinant of this matrix A. How to find out the determinant of matrix A? Can you explain?
Yes, sir. First, we have to choose whether we have to expand in row wise or column wise. Here I have done in row wise. So first taking the A11 element 3 and cross multiplying the minor part of A11. The minor part of A11 is 1 minus 3 minus 1 minus 2. First we have to multiply it downwards 1 into 2. Then we have to imply a minus when we are multiplying upward. Minus of minus 3 into minus 1 is plus 3. So we have to imply that 2 minus 3. 3 of 2 minus 3 results to minus 3. Then we have to apply the same for minus 2 and plus 3. By applying that, we will get determinant of A as minus 17.
So when we apply all these things, we are able to get the determinant value. Okay. So from this, we are able to find out this minus 7 is not equal to 0. And that is why it is non-singular matrix. So once it is proved it is non-singular matrix, then
it is invertible.
It is invertible. So it means what? We are able to find out the inverse of this matrix A. So how to proceed with inverse of matrix A, for which we have to find out the adjoint of A. So how to proceed with the adjoint of A? Explain.
To find adjoint of A, we have to find the cofactors of each and every element of A. After finding the each and every element of cofactors of A, we have to transpose it. So we will get.
Can you work out one, at least let me consider A11. So how you arrived at this minus 1? Can you explain here?
Yes, sir. For
You
A1,
can use a red chalk so that it will be distinct. So now he is going to find out the what? The cofactor of A11 element, and that is represented here as A capital A11. When I put small a11, that represents the element of the matrix. When I put a capital A11 means the respective cofactor. So what do you mean by cofactor? For example, for A11, what is the cofactor?
For A11, minus 1 of I plus j. Here I plus j is 1 plus 1.
Now you can write down A11 is equal to, okay, A11.
A11 is equal to minus 1 of 1 plus 1 into the respective minor. Here the minor is 1, 2, minus 3, minus 1. 1, minus 3, minus 1, 2. So here we get us 1 into 2 minus 3, which is equal to minus 1.
Okay, so in that case, can you introduce a formula for this, a general formula for this cofactor Aij? You can introduce the formula so that it will be comfortable for the students to follow. Is it not?
Sure.
Right.
The formula is
Capital A Ij is equal to minus 1 whole power I plus j into the minor. You can put capital M Ij. Okay, so they are very comfortable, and we can explain this minor also. What do you mean by minor? When you take an element, for example, let me take minus, would be the minor.
Minor of minus 2 is 2, 4, minus 1, 2.
How do you take that minor?
We have to eradicate the first respective row and respective column.
So the relevant columns and rows should be eliminated. That is, it should be hidden, it should be avoided. The remaining elements should be produced as a minor. For example, if you take minus 2 means you cannot take any element in this row and in this column. So the remaining is 2, minus 1, 4, 2. This is called minor of minus 2. What is the minor of 3?
Minor of 3 is 2, 4, 1, 3.
Very good. What is the minor of 3?
1, minus 3, minus 1, 2.
So when you take minor 3, that is the first element, first row, first column means you cannot take the first row and the first column. So the remaining should be taken as the minor. I hope it is very clear for you now. Okay, right, now let us proceed. And this is the adjoint of what? Now we have found out. So we have found out the cofactors, all these cofactors. So can you write down the cofactor first and then take the transpose and declare this as adjoint of A? Can you do that?
Yes, sir.
Okay, you erase it and do this. Now before proceeding, you just explain. Now we have arranged all these cofactors as per the element number. Okay. Now what you are doing to convert this into adjoint A?
We are taking transpose of these cofactors of A.
What do you mean by transpose?
Transpose means interchanging rows and columns.
Okay, so here the row, the column is taken as row. The second column is taken as second row. The third column is taken as the third row. Okay. Good, very good. Now shall we proceed?
Sir.
So we have found out the adjoint of A. Okay. So what is the next formula you are going to employ here? You are going to find out A inverse, is it not? What is that formula? A inverse is equal to?
Reciprocal of determinant A.
Yeah, sure.
Reciprocal of determinant A into adjoint of A.
Okay. Then proceed.
To find A inverse, we have to multiply the
1 by?
1 by determinant of A into adjoint of A.
So what is our value of determinant of A?
We got determinant of A as minus 17.
So you can put minus 17 here. And what is this?
This is the adjoint of A.
Adjoint of A. So that this is the one we have taken here. Now you are multiplying. It is a matrix. You must remember, even though we adopt the method of a determinant, how do you distinguish the matrix and the determinant?
In determinant we just put a straight line, but in matrix we put the brackets.
Square bracket.
Square brackets.
Okay, right. So here it is a square bracket because it is an adjoint, and now we are finding out the A inverse. So for which we are multiplying each element. You must remember, when you put simply determinant means you cannot multiply each element. Either you have to multiply the column or row. But this is not determinant, this is matrix. Once you have found out means that this is an adjoint to the matrix. Are you able to understand? So now you have to multiply minus 1 by 17. Okay. So with every element of this adjoint matrix. Clear? So that is why you have put like this. Right? And now x is equal to what? What is the first formula? That is the first formula. So you are employed at this. What do you mean by x? That is nothing but?
A inverse into B.
A inverse into B. So in that case you can substitute. Okay, you proceed.
To find the x, which is the x, y and z, we are multiplying the A inverse and B. B is 8, 1 and 4. By multiplying these two, we get as x by z equal to 8 by 17 plus 5 by 17 plus 4 by 17, and with the respective of y, 64 by 17 plus 6 by 17 minus 36 by 17. For z, 80 by 17 minus 1 by 17 minus 28 by 17. After calculating this, we get x as 17 by 17, which is equal to 1. And
so
for
you have taken the LCM and the procedure.
Sir. For y, we take 34 by 17. Therefore, we get the y value as 2. And for z, we get 15 by 17. So therefore, z equal to 3. So in final we can understand that x equal to 1, y equal to 2, z equal to 3.
Very good. Actually, here it is only a matrix. That is, it is a single column matrix, and you have got the value as single column matrix. Is it not? And the respective value, and this is simplified one. So you can compare this and arrive at the solution. So this is a matrix, this is also a matrix. You are not getting the exact results, I mean that is equated 3 results here. No. So this is matrix, this is another matrix. I am comparing these two single column matrix. and based on that I am declaring x is equal to 1. The respective elements are same. So that is the strategy we adopt. Are you able to follow? So x is equal to 1, y is equal to 2, z is equal to 3. So this is the way we can solve this linear equation problem involving 3 variables, and the same technique can be adopted for that is 2 by 2 order also, in the case of a linear equation of 2 variables like x and y. Okay, so I must thank Yogesh because he has done this wonderful problem. The presentation is very neat, and one thing is you can include the that is a cofactor and adjoint, how to find out that one also, so that whenever we explain any concept it should be a standalone for which you need not go for any additional reference. All the aspects should be explained. So in this case, what you have missed here to explain as the formula, that is you have not included the
Cofactors.
cofactor. So the cofactor formula here you have introduced. And what is the formula for adjoint? That you can include. So you can erase and introduce that one. Okay? You can erase this one. You can erase this part, and you can declare this as a determinant A is equal, because you already explained. So determinant A is equal to put minus 17. So make use of this space. And that is why I used to tell you that is always leave 1/3 of the space on the right, so that you can introduce all the essential concepts here. All tools must be arranged here. Okay, right, proceed. So the fourth tool should also be included here.
So the fourth is about adjoint, sir.
Adjoint. So adjoint of a ADJ. Now you can introduce as a A11, the transpose of A11, A22, like that. That's enough. Adjoint of A is nothing but is equal to transpose of, that is equal to transpose of matrix of cofactors. Am I right?
Sure.
Okay. So that can be represented like this also. So you already put A11, you know. So you can declare this as a formula. Adjoint of A is equal to put and A11. Am I right? A12. These are all cofactors. 1, 3. A21, A22, A23, and then 31, A32, A33, and what you can put power T. That's all. Got it?
Sure.
So we can represent in this way. So this is the, either you can do like this, or you can simply represent by the formula. Both are same, right? So when you introduce the concept of this one, all these four are very, very important. Okay? So this is the fourth one, right? Okay. Thank you very much.